Good afternoon, welcome to my channel. Last week we studied the Graham's law of diffusion, and this week we'll be applying those formulas which I gave last week to the questions we have on the board. The first question is, if a gas A is 9 times as heavy as hydrogen, which will diffuse faster and by what factor? Don't forget the first formula I gave you, that R1 over R2 is equal to the square root of D2 over the square root of D1. What is the meaning of the R1? R1 means rate of diffusion of first gas, while R2 means rate of diffusion of second gas. And our D1 means vapor density of first gas, while D2 means vapor density of second gas. What is our R1 in this question? Our R1 is the hydrogen. So we have R1 to be rate of diffusion of hydrogen, while R2 is rate of diffusion of gas A. Then what is our vapor density of first gas? From the question, what is the value of that? So D1 is vapor density of first gas is equal to 1, while the vapor density of gas A is 9. So with all these parameters, let's use our formula to continue. So we have R1 over R2 is equal to the square root of 9 over the square root of 1. So what are the square roots of 9? We have R1 over R2 is equal to 3 over 1. And according to the equation, we have to solve which diffuse faster and by what factor. The gas A is unknown, so hydrogen diffuse faster than gas A. The second one is by what factor. The factor is when you cross multiply, you have to what? Give the rate of the first gas with the highest value. So we have R1 is equal to 3, while R2 is equal to 1. So by factor of 3. That is that for the question. So for the Jambite and the YX students, they should be of help to you. So let's move to the second question. A gas X diffuse faster, diffuse twice as fast as gas Y under the same conditions. If the relative molar mass of X is 28, calculate the relative molecular mass of Y. The second formula which I gave last week, where we have R1 over R2 is equal to the square root of M2 over the square root of M1. First and foremost, R1, rate of diffusion of gas X. R2, rate of diffusion of gas Y. Our M1, molar mass of first gas. M2, molar mass of second gas. So with that, from the question, a gas X diffused twice as fast as gas Y. That's what? Twice. So we have 2. R1 is 2, R2 is 1. Why our M1, which is gas X, sorry, we have 28. Then M2, we have Y. So let's substitute all what we have here into that particular formula. So our R1 is 2 divided by 1 is equal to what? Our M2 is unknown, so we have Y. The square root of 28. So the next thing is squaring both sides to remove the square sign. With that, we have the square root of this is equal to the square root of y over 28. We eliminate this out. What the square root of 2? 4 over 1 is equal to y over 28. Then you cross multiply. So we have this. Y is equal to 4 multiplied by 28. So 4 multiplied by 28 will give us y is equal to 112. So therefore M2 is equal to 112. Say 60 cm cube of a gas A diffuse out in 8 seconds and 120 cm cube of another gas B diffuse in 12 seconds. Calculate the rate of diffusion of the two gases. Don't forget, last week I gave you guys formula that rate of diffusion is equal to volume diffuse divided by time taken. And from the question we have to gas. So if you are to attempt question like this, say rate of diffusion of gas A is equal to the volume diffuse of gas A, then divided by time taken of gas A. What is our volume diffuse of gas A? We have 60 cm cube divided by 8 seconds. So 60 divided by 8, we have 7.5 cm cube per seconds. The second one, rate of diffusion of gas B. The same thing, we have the volume diffuse over time taken. So for our gas B, the volume we have 120 cm cube divided by 12. So we have 10 cm cube per seconds. So question like this, you should know the approach to it. Don't forget, rate of diffusion is equal to the volume diffused divided by time taken. So to the next question, they say 100 cm cube of oxygen diffused through a porous partition in 10 seconds. How long will it take 60 cm cube of chlorine to diffuse through the same partition under the same condition? Don't forget the formula whereby we have V1 T2 divided by V2 T1 is equal to the square root of D2 divided by the square root of D1. So the next thing you have to do is we have to write out all the parameters. What is the first volume here? We have 100 cm cube. Our V2, we have 60 cm cube. Then T1, the time taken for the first gas of oxygen, we have 10 seconds. So, excuse me. So T2 is equal to unknown. We don't know it. Then, what is our vapor density of first gas? D1. We have oxygen. We have 16. That is the atomic mass of oxygen, 16. So, vapor density of second gas, that is how long will it take 60 cm cube of chlorine, and the value given for chlorine is 36. So we have this. So with all these parameters here, we can substitute into the what? Formula. So our V1 is 100 cm cube divided multiplied by T2. Or no, we don't know it. Then the square root of D2 we have 36 our V2 we have 60 cm cube. Multiply by, what's our T1? 10 seconds. Cm cube cancel what? Cm cube divided by the square root of 16. So 100 multiplied by T2 we have 100 T2 divided by 60 multiplied by 10 we have 10 seconds. The square root of 36 we have 6. The square root of 16 we have 4. Then we cross multiply. So with that we have 100 T2 multiplied by 4 is equal to 6 times 600 seconds. So we have 400 T2 is equal to 600 times 6. We have 3,600 seconds. So because we are looking for our T2, we divide both sides by the coefficient of T2. We have 400. We also have 400 here. This cancel this. So we have T2. So 3,600 divided by 400. We have 9 seconds. So that is all about Graham's law of diffusion, how to attempt the question. So to all my JAMB and WAEC students out there, with this little approach, I'm sure you can tackle any question under the Graham's law of diffusion, following the formula I gave you last week. Thanks for watching.